Hello learners, welcome to my YouTube channel. Previously, we were in the introduction side of gas law. We have dealt with that side of the Boyle's law. Remember, we said we have several gas laws, which include Boyle's law, Charles law, combined gas law, and Graham's law of diffusion. Today in our lesson 2, we are dealing with the second law, and that's the Charles law. For you to know a law, you are supposed to know something. One of them include you are supposed to be able to state the law. So if you are dealing with Charles law, you are supposed to know how to state the Charles law. That's the first thing. Next, you are supposed to know the graph for the Charles law. Then next, you are supposed to know the formula for that Charles law. After that, you are supposed to know the implication of the Charles law. After that, you are expected to explain the molecular explanation of the Charles law. Then lastly, you are expected to know the application or calculation concerning the Charles law. If you know all this on your fingertip, that means you are done with the Charles law. Let's start with the first, that's stating the law. We are told Charles law states that the volume of fixed mass of a gas is directly proportional to its absolute temperature. To its absolute temperature at a constant pressure. You can define by starting at a constant pressure, comma, the volume of fixed mass of a gas is directly proportional to its absolute temperature. Learners, remember, absolute temperature is measured in Kelvin scale, not the degree Celsius scale. Next, let's go to the graph of the Charles law. You can draw the graph for Charles law in two ways. The first way, you are supposed to have your volume on the y-axis, then have your temperature in the x-axis, but that temperature must be in Kelvin. If it's in Kelvin, that means when the temperature is 0, volume is also 0, then that means the graph will be straight line. So if you decide to use this other way, that's part B. Here, we are using volume, which is measured in centimeter cube, but our temperature, we are using in degree Celsius. So, to convert 0 degree Celsius into 0 Kelvin, it will be negative 273 degree Celsius. So, that means to convert the 0 Kelvin into degree Celsius, it will be negative 273. So, that means the straight line starts from negative 273. Next, let's go to the formula for Charles law. Charles law, the formula is V1T2, which is equal to V2T1. We can derive this by just remembering what the law is saying. We are told volume is directly proportional to its absolute temperature. So if we want to get constant, which is K on the right-hand side, we have to divide here by T. We divide here by T. T will go with T. V over T will give you K, which is constant. So remember, in Charles law, we said volume and absolute temperature are variable, while pressure remains constant. So if V1 over T1, they will vary to V2 and T2. So this will be the formula for calculating Charles law on various conditions. We can simplify this formula by just cross multiplying. So we're remaining with V1 T2, which is equal to V2 T1, as we have on our note here. So after that, let's go to the implication of the Charles law. What does Charles law implies? It implies that when temperature increases, volume increases, and vice versa. That means if temperature decreases, the volume on the other side decreases. Let's go next to the molecular explanation of the Charles law. So increase in temperature of fixed mass of a gas causes an increase in the volume of the gas. Reason? This is because when you increase the temperature, it increases the kinetic energy of the gas particles or the gas molecules, hence they move faster. As the particles move faster, this increases the number of collisions between the reacting particles and the walls of the container. So at a constant pressure, the molecules stay far apart, hence increasing in volume. So thereafter, we are going to go to the application of the Charles law. But before we go to the application of Charles law, we are supposed to be able to convert or know the conversion of temperature scales. So the first one, to convert degree Celsius to Kelvin, what you're supposed to do is you just take the value given, then you add 273. Let's get examples. Convert the following temperatures to Kelvin scale. So I'm given 27 degrees Celsius. So I say 27 plus 273. So 27 plus 273. I'm having 300 Kelvin. So my answer is 300 Kelvin. So if I'm given minus 23 degrees Celsius to convert into Kelvin, I only add plus 273. So here we are having minus 23 plus 273. So we are having 250 Kelvin. So if you are having 0 degrees Celsius, we only add 273. So we are going to get 273 Kelvin. So we are done converting that degree Celsius into Kelvin. Next, let's go to part B. We want to convert Kelvin scale to degree Celsius. So what we are supposed to do is we take the value given, then we subtract 273 from the value given. So let's get examples. Convert the following temperatures into degree Celsius. So if you are having 300 degrees Celsius and we want to 300 Kelvin and we want to convert into degree Celsius, we said 300 minus 273. Here we are going to get 23 degrees Celsius. Let's check 300 minus 273. So my answer is 27 degrees Celsius. Next, if you are having 100 Kelvin, 100 minus 273, you are going to get 100 minus 273. You are going to get negative 173 degrees Celsius. Next, we are having 44 Kelvin. 44 Kelvin, we subtract 273. What are we going to get? So we are going to have 44 minus 273. So we are going to get negative 29 degrees Celsius. Lastly, we are having negative 25 Kelvin. We just subtract from 273. Then what are we going to get? Negative 25 minus 273. We are going to get negative 298. Negative 298 degrees Celsius. So, learners, what we are saying is when you are converting temperature scales, you are supposed to remember only two things. If you are converting from degrees Celsius to Kelvin, you add 273. If you are converting from Kelvin scale to degrees Celsius, you are expected to subtract 273 from the value given. Next, let's go, learners, to the extended questions. You are supposed to attempt these two questions in our next class. I'm going to go through the comment section. Next class, we are going to be dealing with application or the calculation of the Charles law. Thank you. Goodbye.